Hello everyone, today I will present our work for the Orbit Challenge. Our team name is ORBITRON and this team consists of myself, Christian and also Peng Fei. And unfortunately we cannot make it to the conference this year, but hopefully we can meet in person at another time. Before going to the detail, we want to highlight the Orbit dataset, which has high variation features with some challenges. For instance, unbalanced classes, lighting variation, background variation, viewpoint variation, ill-frame objects, and also blur. So our method somehow can tackle some of these problems. So this is the overview of our method. In standard image classification, we have input images, a backbone, it can be ResNet or EfficientNet, and then fully connected layer, and then the prediction. So the objective in few shot learning is to learn unseen classes with a few labeled data. So how to do that? We train on base classes and use the model for transfer learning. Given a few images, we want to adapt this FC layer on novel classes. So our work is motivated especially by the work of Char et al. So they replace the weights in the FC layer with prototypes because they observe that when they plot the feature representations from the images under the same class and then the FC layer, so they are somehow corresponding. And in our proposed method, so this is the premise that images lie on a lower dimensional manifold, and we tried a few images as a classifier to replace the FC layer without further parameter updates, and we model it using a subspace. I will go into detail in the next slide. So the question here is that how to make the FC layer to be dynamic and adaptive to a given context. Especially in this challenge, we know that for each user, we need to personalize to their own needs, and the FC layer needs to be changed as well. So in visual learning, actually, there are some prior approaches using dynamic classifiers. So these dynamic classifiers basically mean that the classifiers can change between episodes. And here, one of the examples that people could use is the prototypical network, where the feature representations here are averaged to get this WC that represent a class, and then we calculate the distance. So the distance can be the difference between the prototype and then the feature representations of the query image, or the dot product between them. Our work is motivated by the work of Basri et al. Here, image instances from different lighting conditions, multiple views, noisy images within a class can be represented in a low dimensional space. So this actually corresponds to the challenge from the Orbit dataset that has different lighting conditions, multiple views, and also noisy images. So I believe that subspace can be beneficial for tackling all of these challenges. And the benefit of using subspaces here, it is more robust to missing data since the subspace can fill in the missing pictures. As you can see here, the subspace represents mass, so the subspace can only be created from 2 images but can somehow fill in some missing points here. This is the formulation of our work, the subspace methods as classifiers. So we project each data point within the same class to a subspace. Here the projection is made of the P matrix for each class. So this P matrix can be obtained from n leading principal component of U, where U is the orthogonal basis for linear subspace spanning all of the representations from images under the same class. In our experiment, we showed that our method can achieve 0.74 for the frame accuracy and achieve the best performance on the leaderboard. We use CNN backbone EfficientNet B0 and image size of 224 times 224, and we get the video accuracy 0.76, frames to recognition 0.176. To conclude, trading a set of images with different conditions, lightings, viewpoints under the same class as a subspace, we can achieve the best performance on the leaderboard. We also observed that the simple modification in the classifiers as subspaces can work better compared to the baselines for the cluttered images in the test set. Thank you.